All right, here we go. We've got question 5, which is all about electricity. Okay, we've had a few mechanical experiments recently, some with thermal, and this is your classic electricity experiment. As ever, please take some time to have a look at the question, and when you're ready to go, watch on to see my explanation of the answer, or my attempt to explain the answers. I don't think I've explained them all very well. Okay, we've got our setup. Now we should be aware of this. Now, big red flag, they've put a letter Y next to this thing here. You're going to be asked what that's called, okay? Because any unnamed component is usually something that you will have to understand or name, okay? We're told a procedure. We're told that we slowly adjust component Y until V is equal to 0.3. We record current and potential difference using the voltmeter and the ammeter, okay? And there we go, right at the top there, state the name of component Y. Well, as you're all aware, this is called a rheostat. No, this is a variable resistor. Also called a rheostat, but nobody will call it that because it's a weird spelling and nobody really refers to it in that way. Okay, this is a variable resistor, a resistor who can change its resistance. Now, let's go through and have a little look at some more. Okay, here we go, classic setup. We've got an analog display, so we're going to be asked to measure V and I. Yeah, in this case, we've got 0 to 1. Each big division consists of 5 small divisions, and each of those consists of 5 more. So we're having to divide by 5s. In this case, we're going from 1 to 2. We're going 1.2, 1.4, 1.6, 1.8. On this side, similar, okay, 0.2 to 1. However, we've got to be a bit careful. Each of those divisions is 0.02. Let me just get it right. So 0.82, 0.84, 0.86. This guy is in the middle, that's 0.85. And you can guess, obviously, as you know if you've done the question, we're being asked to calculate resistance. So I've filled in my table, that's my 1.8 volts, my 0.85. Notice all the other values are given to 85 as well. Don't go any more. Some students get tempted to go 0.87, 0.83. You can't measure that, it's just halfway, so therefore 0.85 is fine. Now, a word about the resistance. Obviously, we've used the equation V over I, which you're given. It's a nice thing to be given here. Not expected to recall. However, you need to make sure that you're consistent with your presentation of the data. So everything here has been given to 1 decimal place. You should give everything else to 1 decimal place as well, or in this case, 2 significant figures. So there you go. We've got 0.8, 1.3, 1.7, 2.1. This 2.11 becomes 2.1. Now it says here, next question. This is an interesting one. I think my answer could be a bit annoying, so we'll come to this. Okay. We've been asked, why is it good experimental practice to open the switch between the readings? Okay, now there's a few different ways of answering this question. The first one could be that we don't want to run the battery down, right? We don't want to run out of electricity. Now, it's using a power supply, so the power supply, probably not a problem. If you're using a cell, then fair enough, yeah, you might not want to run down the cell. Big one here is it avoids heating up. Now in the answer they've just said, in the mark scheme they've said heating up of the components. I've said heating up of the resistor, because of the resistor. And I realised actually the resistor's not, there's only a variable resistor, so maybe I've been a bit too vague here. This would affect the resistance. I think I'd still get the marks here. Heating up circuits is generally not a good idea. Okay, the reason for that is 2. 1, it's unsafe. It can cause melting of the wires and then obviously an electrical fault, or it can change the resistance of the components you're using. Okay, so our variable resistor will change its resistance. Okay, ignore the people singing the alphabet song in the background. Okay, it would affect the resistance and therefore impact your experiment. Okay, so if in doubt, just say heating up is to be avoided. Okay, and if you don't really need to have to give a reading here, it could affect the resistance and it could be dangerous as well. Okay, let's keep going, if we can ignore the noise. All right, now, in this case here, we've been asked to plot the graph. I'm really delighted that we've got a graph plotting question to do. Kind of annoyed by how I've framed my screen because it doesn't look like it's all going to fit in. Okay, so I'll see what I can do about that. All right, graphs. We should be delighted when we get graph questions. Okay, now I plotted mine in pen. You should do yours in pencil, because you can see here I made a mistake. These little exclamation marks just saying don't pay any attention here. The graph questions, just to scroll down, are for 3 marks. And the 3 marks are for follows. 1, that your axes are labelled. So we're plotting R with ohms. You must have a unit. If you don't have the units, then you are not going to get the mark. And V in volts. That's nice. Okay, R in this case has to be on the y-axis because you're told it should be on the y-axis. And V should be on the x-axis. If you've got them the wrong way around, you will not get the marks. Okay, you've then got to choose a suitable scale. All right, now the suitable scale in a sense is fairly simple. The way that I did my suitable scale is I looked at the top value of the resistance and the bottom value of the resistance. And I thought, how can I fit that in? Now, if you take these 6 boxes, that suggests 0.3 per box. Do not use 0.3. CIE likes these divisions to be 10s, maybe 20s, but never 30s or 40s or 60s or 70s or 80s, okay, or 90s. Usually in hundreds, 10s, 1s, 2s, 5s, 50s, okay? So in this case, I've gone for 0.5, all right, up on the y-axis. And then on the bottom, I've actually done exactly the same, 0.5, right? So this is a really nice one to do. So you need to draw your suitable scale. It should use over half of the paper, okay? If you've got a tiny little graph, then you will lose this mark. So make sure it's using over half, and you can see that there I've used loads of the space. That means it's easier to read. Last point here is the points. Now, I'll be honest with you, I did this really quickly, so I may have made a mistake. I know that I made a mistake here, okay? However, I redrew that. When you are doing it, check, check, check again. There is someone, and believe me, I've done this job, you go and check every single point. And if you lose one of them, then you lose all of the marks here. So if you lose the whole mark here. So if one of these is out, there's no benefit of the doubt or anything like that, you just lose the whole thing, okay? Lose that mark for the points. The other thing that they insist on is crosses. Crosses are just easy to read. So if you draw, and this is a scientific term, a blob, you will lose the mark there as well, okay? So make sure you're using crosses. So you can see it's very easy to get marks in this, but it's also really easy to lose marks. So please just be careful when you're drawing your graph. Use a ruler, use pencil, make sure it's nice and neat, use crosses, you'll get the marks here. And this is, a good proportion of your score, 4 out of 60 marks, always for a graph. I've said 3 marks there. Where's the next mark? The line of best fit. Now, it does not say straight line. So you don't have to draw a straight line. So I've drawn a smooth curve through my data point. I've tried to draw that. I find it hard to draw this one. Again, I was doing it very quickly. Take your time. If it doesn't say straight line, you do not have to draw a straight line. Now, here's the bit that's interesting. Use your graph to describe the relationship between R and V. This is a 1 mark question, and notice that they do not say anything about proportionality. That's going to come later. All we can say with this is that as V increases, R increases. That's it. Yeah. You're expected simply to be identifying that the 2 things increase together. Now, are they directly proportional? This is the test. Okay, we're going to say whether they're correct. I'll be honest with you, you might be tempted to kind of go for that, all right? However, the answer here is no. If these 2 things were to be directly proportional, then what we would then draw here is a straight line through the origin. It would have to be 0, 0, and going all the way through as a straight line. This is a curve which does not pass through the origin, not at least as I've drawn it, and so therefore this is not directly proportional relationship. A lot of students think that things going up together means directly proportional. It does not. When we're looking for directly proportional, we're looking for the idea that as V doubles, R will also double, and that is not the case here, and so therefore we do not say directly proportional.